When we hear Nvidia, we immediately think of powerful video cards for computer games. But in reality, it's a vast ecosystem of chips that powers gaming consoles, workstations, supercomputers, servers, artificial intelligence, and even modern cars. In this video, we'll take a detailed look at all of the company's key product lines: GeForce, Quadro, Tesla, Titan, Grid, Jetson, DGX, and Tegra. You'll learn their key differences, the tasks they were designed for, and the technologies hidden under their casings. Let's start with the iconic GeForce series. This is Nvidia's most widely recognized and widely used line. It all began back in 1999 with the iconic GeForce 256, which revolutionized the industry. Before its arrival, 3D graphics looked primitive: blocky models, minimal effects, and constant stuttering. GeForce was the world's first graphics card where all the heavy lifting of 3D scene calculations was handled by the graphics chip itself rather than the CPU. It was then that games evolved into fully fledged 3D worlds. Today, the series is clearly divided into generations and classes. GT are entry-level graphics cards designed for the most basic office and multimedia tasks. GTX are time-tested gaming classics, but without hardware support for ray tracing. RTX are modern graphics cards equipped with ray tracing and tensor cores for full-fledged ray tracing and intelligent DLSS anti-aliasing. The current RTX lineup also has its own clear hierarchy. RTX 50. Affordable entry-level graphics card and esports. Best for online shooters, CS2, Dota 2, Valorant, at high FPS in Full HD, basic video editing, and simple 3D for learning. RTX 60, popular hit and blogging. Best for maximum settings in Full HD and comfortable gaming in 2K. RTX 70, the optimal balance for enthusiasts. Best for uncompromising 2K gaming at ultra settings with heavy ray tracing, path tracing, working with demanding 3D graphics. RTX 80, premium for 4K and heavy work. Best for confident gaming in native 4K at maximum settings. RTX 90, the uncompromising flagship. Best for extreme gaming, 4K/8K, heavy mods, VR. Game development with Unreal Engine 5, training complex neural networks, machine learning, and rendering gigantic 3D environments. For developers, AI engineers, and anyone who needs maximum computing power regardless of budget. Quadro, Nvidia RTX Pro 241. The Quadro line, now officially called Nvidia RTX Pro, is a completely different story. While GeForce delighted gamers with vibrant images, Quadro drove progress behind the scenes. Its main users are architects, engineers, and 3D designers. The key feature here is phenomenal stability and specialized driver certification for professional software. To give you an idea of the scale, the latest card in this series is based on the same chip as the flagship RTX 5090, but it has an astronomical 96 gigabytes of memory. Tesla. Until 2020, Nvidia released the specialized Tesla series, designed for complex scientific calculations and server data centers. Now these accelerators are released under simplified alphanumeric indexes like A100 or H100. You won't find video outputs on them, and you won't be able to run games on them. Their focus is deep machine learning, working with artificial intelligence, and support for the most powerful supercomputers. The Titan series occupied the space between GeForce gaming cards and Quadro professional cards. It was the company's way of demonstrating what the perfect GPU looked like. Revolutionary. When the first Titan launched in 2013, it stunned the market. It was a consumer card that, for the first time, allowed users to do everything: run games, accelerate creative tasks, and even train neural networks right at home. Titan became a symbol of ambition and a tool for those who wanted the impossible from hardware. The line included models such as the Titan X, Titan V, and Titan RTX. Currently, the Titan series is no longer produced as a separate brand. Its functions have essentially been transferred to flagships like the RTX 5090 and professional RTX Pro 6000 ADA cards, which combine the capabilities of both niches. Nvidia Grid is a family of graphics processing units, GPUs, developed by Nvidia and introduced in 2008. They were specifically designed for GPU virtualization and cloud gaming. Nvidia GD combines both graphics processing and video encoding in a single device, reducing display latency when streaming video games to the cloud. Two graphics cards were available, the Grid K1 and GD K2. Today, Nvidia Grid is the fundamental technology underlying modern Nvidia graphics virtualization solutions. It allows you to run heavy applications and 3D graphics on remote servers and work with all this on a low-end laptop. This technology underlies GeForce Now, cloud gaming, and enterprise virtual desktop solutions. Jetson is a GPU-based mini-computer that combines ARM processors and graphics. It's designed for robotics, drones, smart cameras, and AI-powered devices. It can recognize faces, analyze video, and navigate spatially. Models like the Jetson No and Orin allow you to run neural networks and computer vision directly on the device without a cloud connection. Nvidia DJX is a series of ready-to-use supercomputers and servers for EI. Each one features several professional-grade GPUs, such as the A100, H200, or later models mentioned earlier, connected via NVLink and NVSwitch. DGX is used in labs, universities, and even companies like OpenAI and Tesla. These aren't just graphics cards, they're infrastructure for training large language models and EI systems. Here's what the latest models of these computers look like. The Nvidia DJX B200 and DJX Spark. The price of Nvidia DJX systems varies greatly depending on the model and configuration, from approximately $4,000 for a desktop PC for developers to over $1 million for full-scale enterprise-scale supercomputer clusters. Tegra is a system-on-a-chip, SoC, that combines a CPU and a GPU. The first versions appeared on the Zoo HD player, early Android tablets, the Nvidia Shield, and even the OA console. But back then, none of it took off. Then came 2017, and Tegra finally found its niche. It became the heart of the Nintendo Switch. Inside the console was a custom Tegra X1 chip. The new second S1 uses the Nvidia Tegra T239, so given the popularity of S1s, we can confidently say that Tegra brings the GeForce architecture to a compact device, delivering powerful graphics with low power consumption. Put it all together, Nvidia doesn't just make graphics cards, it creates tools for every world. GeForce for gamers, Quadro for professionals, Tesla DJX for science, Titan for enthusiasts, Jetson integration, and Grid for the cloud. That's all. Thanks for watching.